Greetings to all. I'm Himanshi. I'm a third-year undergraduate at Department of Physics, IIT Roorkee, and today I'm giving a presentation on digital code lock using 8051 microcontroller. So let's get started. Giving an outline of this presentation, I'll start by giving a basic introduction, then explaining what is a digital lock. Then we'll go through the flowchart and its components. Then I'll explain the working, the circuitry, and the code. Then I'll finish this presentation by reading out applications and advantages and its limitations. So giving an introduction, a password-based door lock system using 8051 microcontroller is a simple project where a secure password will act as a door unlocking system. Traditional lock systems using mechanical lock and key mechanisms are being replaced by new advanced techniques of locking systems. These techniques are an integration of mechanical and electronic devices and which are highly intelligent. One of the prominent features is its simplicity and high efficiency. Such an automated lock system consists of electronic control assembly, which controls the output through a password. This output load can be a motor or a lamp or any other mechanical or electrical load. Here we'll understand how to design a password-based lock system using 8051 microcontroller. It is simply an embedded system with input from keyboard and the output being actuated accordingly. This system will demonstrate a password-based door lock system using 8051 microcontroller, wherein once the correct code or password is entered, the door is open and the concerned person is allowed to access to the secured area. Again, if another person arrives, it will ask to enter the password. If the password is wrong, then the door would remain closed, denying access to the person. So what is a digital door lock? I've already explained in the introduction, but it's like a password-based electronic code lock. In this presentation, we'll see how to design a digital door lock using 8051 microcontroller, a keypad, and a 12-volt DC relay. So the flowchart explains that once a person enters the password, we'll check if the password is correct. If it is correct, then the door will open. If it is wrong, it will ask the person to re-enter the password. If it is wrong again, it will the cycle will continue 3 times. If it is again wrong, then the alarm will ring. The components to design is 8051 microcontroller, 4x4 keypad module, buzzer, 16x2 LCD display, resistor, pull-up resistor, capacitor, red LED, breadboard, IC7805, 11.0595 MHz crystal, power supply, and connecting wires. So here we can see a general block diagram of 8051 microcontroller. I'll explain the working. This system mainly consists of 8051 microcontroller, keypad module, buzzer, and LCD. 8051 microcontroller controls the complete processes like taking the password from keypad module, comparing passwords to predefined password, driving buzzer, and send status to the LED display. Keypad is used for entering password into the microcontroller. Buzzer is used for indication of wrong password, and LCD is used for displaying status or messages on it. Buzzer has an inbuilt driver by using an NPN transistor. So to take input from 4x4 keypad matrix using multiplexing technique. In this circuit, we have used multiplexing technique to interface keypad to the 8051 microcontroller for entering the password in the system. Here we are using a 4x4 keypad which has 16 keys. If we want to use 16 keys, then we'll need a 16-pin connection to the microcontroller, but in multiplexing technique, we need to use only 8 pins for interfacing 16 keys, so that it is a smart way to interface the keypad module. Multiplexing technique is a very efficient way to reduce number of pins used within the microcontroller for providing the input or password. Basically, this technique is used in 2 ways. One is row scanning, another is column scanning. Here we are going to explain row scanning. First, we must define 8 pin for keypad module, in which first 4 pins are column, last 4 pins are rows. You can see in the diagram. For row scanning, we need to give data or signal to the column pins and read the data or signal from row pin. Now suppose we give below data to column pins and we read this data at row pins. If user presses key number 1, then R1 changes high to low, means R1 is 0, and controller understands the user has pressed key 1. And then it will print 1 on the LCD and store 1 in the array. So this high to low change at R1 is the main thing by which controller understands that some key corresponding to column 1 has been pressed. Now if the user presses key number 2, then R1 remains at high, as C1 and R1 both are already at high, hence there will be no change. It means microcontroller understands that nothing has been pressed in column 1, and likewise this principle goes for all another pins. So in this step, controller only waits for keys in the column 1, 1, 4, 7 and star. Now we want to track keys in the other columns, like in column number 2. Then we need to change the data at column pins. This time controller only waits for key in column 2, which are 2, 5, 8 and 0, because change high to low only occurs when column keys will be pressed. If we press any key in column 1, 3 or 4, then no change will occur, because these columns are at high and rows are already at high. So likewise, keys in column C3 and C4 can also be tracked by making them 0 at a time. The circuit diagram for digital clock using 8051 has been shown in the next slide. The keypad module column pins are directly connected to pin P0.2, P0.1, P0.2, and P0.3, and row pins are connected to P0.4, P0.5, P0.6, P0.7 of 8051 microcontrollers port 0. A LCD is connected with 8051 microcontroller in 4-bit mode. Control pin RS, RW, and EN are directly connected to pin P1.0, GND, and P1.2. Data pins D4 to D7 is connected to pins P1.4, P1.5, P1.6, and P1.7 of the microcontroller, and one buzzer is connected at P2.6 through the resistor. You can see the circuit diagram. Now the code. By using a predefined password in the program, this password can be defined by the user in the code. When the user enters a password to the system compares the user entered password with the stored or predefined password in the code. If a match occurs, then the LCD will show access granted, and if the password doesn't match, then the LCD will show access denied, and the buzzer will continuously beep for some time. Here we have used the string.h library. By using this library, we can compare or match two strings. In this program, we first of all we will include header file and define variable and input and output pins for keypad and LCD. A function for creating delay of 1 second has been created along with some LCD functions like for LCD initialization, printing the string, for commands, etc. After this, in the main program, we have initialized LCD and then we read input from keypad using keypad function and stores input keys into array, then compare it from predefined array data using strncmp. If the entered password is matched, then the accept function is called, and if the password is wrong function is called, as you can see. Now coming on to the applications of password-based door lock system. This simple circuit can be used at residential places to ensure better safety. It can be used at organizations to ensure authorized access to highly secured places. With slight modification in this project, it can be used to control switching of loads through password. The advantages of this are this provides security. The power consumption is very less. It is the components are very commonly available. It is very simple and easy to make. The limitations are it is a low end circuit, so that is it is not possible to operate the circuit remotely. If you forget the password, then it is not possible to open the lock. That would be all. Thank you.